So this video is for your review for Unit 1, which is taken from Chapter 2 of your book. And question 1 says, James launched a bottle rocket off the edge of a cliff. The height of the bottle rocket in feet above the surface of the ground beneath the cliff can be estimated by the equation h at t equals negative 16t squared plus 60t plus 160, where t is the time in seconds after the launch of the rocket. How high is the cliff? Well, the height of the cliff would be represented by the starting height, because that's where it's thrown from. And I remember when we did our quadratics that we set our c value when no time has passed. If we put a 0 in for t here, that becomes 0. And the 0 here, this becomes 0, and we're just left with 160 feet. How high will the rocket be in 5 seconds after the launch? Negative 16, 5 squared, plus 60 times 5, plus 160, because it's 5 seconds after the launch, and t is the time in seconds after the launch. I'm going to put that in my calculator. Right, so I've typed it in my calculator, and I get 60 feet. So I'm going to put that on my paper. 60 feet. Right, my next question asks, at what time or times will the rocket reach 200 feet? When will the rocket reach 200 feet? I'm going to go to my calculator. All right, so I'm going to go to my calculator, I'm going to go to y equals, and I'm going to go ahead and I'm going to type the equation in that I've got here. I'm going to, of course, have to use x instead of t. And I'm making mistakes here. Let's try this again. Okay, so I've typed my equation in my quadratic, negative 16x squared plus 60x plus 160. And when I go to graph this, right now my window for my calculator is on what we call a standard window. So if I graph it, I can't really see a lot of my graph. I can't see the highest point that it reaches. So I'm going to go ahead and change my window a little bit. I realize I really need to change my y. And I don't need all this space over here for my x either. So I'm going to go to my window and maybe start my x at negative 5. And then my y, I'm not really sure. So I know that I toss it from a height of 160. I don't know how high it's going to go. Let's just say 300. I have no idea. Let's see how that graph looks. And look, I can see the entire path of the object. I guess it's a bottle rocket. And I want to know, when is the height going to be 200? So what I'm going to do is I'm going to go to y equals, and I'm going to go down to y2, and I'm going to say, well, when will the y or the height be 200? And I'm going to look at my graph. And that red line there shows me the 2 times right here and right here when it's going to be 200. And I want to know exactly when that's going to be, so I'm going to go to second trace. And I'm looking for the intersection of my 2 graphs, so I choose intersect. And the flashing spider, as I call it, says it's on the first curve on that quadratic. Yes, it is, so I hit enter. Now it's on the red curve, and I'm going to hit enter. The guess, now you have to realize, because both of these are very close to the intersection point on the right, that's the one it's going to find. So I hit enter again, and one of my intersection points is at 2.88 seconds. It will be at a height of 200 feet. So I know that one of my answers is at 2.88 seconds. That's one of my answers. But I'm going to go back to my calculator, and I want to find my other point of intersection. So I'm going to go to second trace. I'm going to choose intersect again. And this time, though I am on the first curve, I need to move it so that it's closer to that other point of intersection. So now I'll hit enter. Yes, I'm on the second curve, close to that other point. Enter again, and I find that at 0.86 or 8.87, did that tell me what to round to? It did not, so I'll go to 2 decimal places since I did 2 decimal places for the last one. So at 0.87 seconds. So at 0.87 seconds. So those are the 2 times that the rocket's going to reach 200 feet. The next question says approximately how long, all right, so again, it's going to be a measure of time. After the launch, will the rocket hit the ground? Hitting the ground is when it hits the x-axis, which is called a 0. So I'm going to look for a 0. So I'm going to go back to my calculator. All right, I'm going to go back to y equals. I'm going to get rid of that 200 for the y2. I don't need that anymore. And I'm going to simply look at the graph. And this time I want to know when it will hit the ground. Over here in the negative, I don't need that answer. I only need my positive answer. So I'm going to go to second trace. This time I want the 0, because I'm looking for when it hits the x-axis, x-intercept. And it wants to know if it's to the left of that point. It is. I'm just going to get a little closer to it. So notice here's my x-intercept, and I'm to the left and above. I hit enter. Now I need to move to the right of that, and I have to make sure I'm below. And I know I'm below because my y is negative, so I hit enter. Don't worry about the guess. And at 5.55 seconds, I'm at y equals 0, which means I've hit the ground. So I'm at 5.55 seconds. Right. Okay, so my next question 2, a ball is thrown upward from a height of 30 meters. Okay, that's going to be my initial height with an initial velocity of 25. That's going to be my v sub 0. What is the maximum height in meters reached by the ball? So because I'm doing everything in meters, my gravity is going to be measured as 9.8 meters per second squared. And this is where I'm going to use that equation, h at t equals negative 1/2 gt squared plus the initial velocity times t plus the initial height. You will be given this equation. So I'm going to start substituting. H at t equals negative 1/2 times 9.8, which gives me negative 4.9 t squared plus my initial velocity, it's 25 mt, and my initial height is 30. So because I want to know the maximum height, I'm going to need to go to my calculator and put this in. Right. So I put my equation in the calculator. I haven't changed my window since the last problem. I'm going to see if this window works. And I can see it. I don't need all this extra part of the graph, but I can see my max height. So there's no need to change my window. So I'm going to go to second trace. And I'm going to find that maximum. And I need to make sure that I'm to the left of that max, and I'm definitely to the left. Above and below doesn't matter, only on zeros does that matter. Now I'm going to go to the right. Enter, don't worry about the guess. And my max height is at 2.55 seconds, I reach a max height of 89 meters. Does it say what to round to? It does not. So I will just go, I guess, 2 decimal places. So that's 61.89 meters. The time didn't matter. It just asked what the height of the ball would be. So that's the only part of the answer I need to get. How high will the ball be after 3 seconds? I'm simply going to substitute a 3 in here and here. And put that in my calculator. Right, so I put this in my calculator, I hit enter, and 60.9 is going to be the height of the ball after 3 seconds. I want to encourage you to make sure you're typing this into your calculator. Many people on a test will say, well, I put it in my calculator wrong. And that can happen because you're not practicing with the calculator. So please make sure that you're getting the same answers that I'm getting. So 60.9 meters. Okay, my next question. The half-life of a certain radioactive substance is 30 days. It's a half-life problem, so I know it's exponential, and I know that my growth factor is going to be 0.5. To the nearest 1,000, that's 3 decimal places. How much of a 10-gram sample, so I'm starting off with 10 grams, half-life will be left after 85 days. So I've got 85 days as my total, and 30 days is time and a half-life. So that's going to be raised to the 85 divided by 30 power. Total days over time in a half-life. So I'm going to put this in my calculator. This is one that there typically are a lot of calculator issues. So you want to make sure you put it in your calculator correctly. Okay, put it in my calculator. I make sure that I have parentheses from my exponent. And I get that I would have approximately 1.403 grams remaining. So 1.043 grams. Okay. All right, it takes the human body 8 days to filter half of a new medication called Clear My Lungs. Okay, so 8 days is going to be the half-life. So this is another half-life problem. How many milligrams of a 30 milligram dose, so I'm starting off with 30 milligrams, will remain in the body after 13 days. 13 days is my total, and 8 days is my time and a half-life. So this is going to be 13 divided by 8. So I want to make sure I have, again, my exponent in parentheses, and I go to my calculator. And does it tell me what to round to? It does not, so I'll round to 2 decimal places and say 9.73 milligrams. 73 milligrams, so there's my answer. Okay, let's go on our next page. The equation is going to be 530,000 times 1.002 to the x can be used to model a country's population X years after 1979. So this is years since 1979. The country's population in 1985 was 536,392. What is the residual? As soon as I see residual, I have to remind myself that residual is always equal to actual minus predicted. So the actual population in 1985 is 536,392 minus, I need to find my prediction. Well, from 1979 to 1985, there are 6 years that have passed. So I'm going to need to put a 6 right here for x. So I'm going to go to my calculator. And I get, that is my population. So I'm going to put that on my paper. And since residual is actual minus observed, I'm going to type this in my calculator, the actual value. And I'm going to subtract the predicted, which I just found. And I'm just going to go ahead and use the exact. And I'll do my rounding at the end. And I get, wow, not very high of a residual at all. I get 0.1151. And so it must be a very